for portable measurement systems for aerospace. So together with the Metrologic Group, API is happy to present you how we can combine our software and hardware to have a more fast, accurate, and flexible solution for the production, especially in aerospace, but for sure not only limited. In advance, this is a webinar based on Zoom, and please be informed this session will be recorded. Your microphones are switched off or will be muted. And in case you have any questions or remark, please use the Q&A session here in the Zoom webinar. And the recording of this webinar can be provided afterwards. And now I'm happy to introduce also Charlie and Clément. So both should be here in the call. And maybe just a few words to my person. I'm the general manager of API in Europe, Middle East, and Africa. And we are working closely here together with Metrologic or with the Metrologic Group to support the customer base and find the best solutions for you. So Charlie, if you want to introduce yourself.
Of course, thank you, Jan. So I'm Charles Carbillet, nickname Charlie. I'm the product marketing of Metrologic, working here since now 25 years. Be involved on the software development on our Metrologic solution X4.
Clément?
Yes, hello everyone. I am Clément, application engineer at Metrologic. I am in charge of the managing demonstration, creation of some demo kit, and create a link between the marketing team and the technical side of the soft.
Okay, excellent. Yeah, what we have prepared for today, we have a short overview about the company Metrologic, about the solution of Metrologic Group. I think, Charlie, you may introduce this part. Afterwards, I give a rough overview about API and our product lines, our product portfolio. And finally, we have prepared small video demonstrations on how we can utilize API equipment combined with the Metrolog and have some advantages in this combination. So I think we have these three parts, and I would like to hand over to Charles to start with the part of Metrologic.
Okay, thank you, Jan. So let's speak about Metrologic. We are a society that was built, I would say, in the 1980s, mainly for hardware electronics purpose, but soon the company start to be more a software editor for the 3D measurement or 3D inspection software to address different technology, because we are focusing on the universality of our application. So since now 44 years, we are focused on the 3D measurements, the CMM retrofits, automation inspection, and also services inspection according to the calibration of the machine or part programming services. We are located in France. And next slide, please. As you can see, we are also global in terms of worldwide representation, because we have around 6 different sales offices located in the different countries, as you can see here, and also different resellers in a local country, as you can see also in this drawing. We are around 20 interface language different for the software. That means we can address mainly all the worldwide region or area. We have a representative users on over than 60 different countries. And also we support plus 30 plus countries for local supports. Next slide. Very quickly, we have, let's say, a hand-to-hand process in order to address your inspection need. And we have split this approach, this offer, in 4 different steps. The first one is a prepare phase, where you are going to prepare your inspection plan. The second one will be the offline programming. It means you are going to use your inspection plan and build your part program according the digital twin of your environment. The third one is the one we are going to focus on. This is the execution of this part program or the measurement directly on the device. It is Metrologic Explorer. And the fourth one, which is after collecting the data, we are going to monitor, to export, to expose the information, the result information, but also the status of the device or the status of the project in a specific database management system, for example. So this is our four step, 1, 2, 3, 4, and we are going to focus on the third one. Next slide. Thank you very much. So we are going to focus on Metrologic Explorer as a universal software, but here today we are here to speak about the connection with API technology. Thanks to this software architecture, we are really based on the different computer, high-performing 64-bit architecture, of course, but we are also more oriented for the inspection with the different GD&T evaluation, with the different capability of reporting, using big point cloud data to manage the different analyses that the customers is finally need to get. According to that, you can get a very manual process approach, or you can get also automated thanks to a programming engine able to reproduce with a robust way the different process that the final customer would like to use. Next slide. So thanks to this approach with a standalone laser tracker as API, we are able to address, let's say, the large-scale metrology scenarios. That means probably you have a massive part and you would like to control this massive part with a different position or with a different environment. Maybe you are not in a basic or stable environment. You are able to manage that thanks to the different technology through the hardware, for sure, because the API laser is able to work on it, but also thanks to the software, which is able to combine different stations as a bundle activity to take the different uncertainty of the different position for the hardware and take that inside the same software, inside the same environment to be able to manage directly or postpone your analysis in a couple of minutes or a couple of days, according to your constraint on the shop floor. I think this is the last slide for me. Jan, yeah, it's your turn.
That's right. Thanks for your introduction of Metrologic. And of course, hardware is always as good as the software and the way around. So we need to collect the data and we need to process the data. And from the hardware side, I'm glad to introduce API. Some or most of you may already know API, but just to recap, API stands for Automation, Precision, and Innovation. Our CEO, owner of the company, has developed the laser tracker technology more than 35 years ago, and was one of the pioneers of the portable metrology systems. Over the years, we developed new generation of laser tracker, new generation of laser-based system, and we could establish a global footprint of API facilities all over the world with our headquarters in the US and our European headquarters here in Heidelberg in Germany. So we have facilities in Asia, in South America, and a lot of different partners, resellers, and service companies supporting our global approach to be global local. And the task of API, or our vision of API, is always that we support our customer to solve complex production or measurement tasks with high speed or pretty fast and efficient. We want to support you in increasing your productivity and reducing the costs. And that's the reason we are focused on really custom-made and automated and customer-focused metrology solutions, which can be integrated in the manufacturing process. So this said, looking into the aerospace, I think we can, well, everybody knows what are the requirements from the aerospace industry. And for sure, it's always about precision accuracy, but we also need to make sure that we can provide high quality, top quality control systems for safety and reliability. So if you look into our portfolio, we have multiple systems which supports this approach, mainly driven by the API Radian Laser Tracker, as well as the 9D Laser, where we had another webinar with Metrologic already some months ago. And combining those technologies, we can really support your measurement tasks and to make sure that everything is solved as requested and in an efficient way. What are the portfolio of API? For sure, I just give you a rough overview today, mainly driven by the laser tracker and accessories product line, including the 6 DOF systems. We also use the automated solutions technology, so we combine our API products, different types, to find automated solution for you. We can provide solutions for machine tool and CMM calibration, as well as robot calibration and verification. With our newest technology, we have a handheld scanner for scanning applications, and our global services supports all our customers worldwide with training, consulting, and if needed, also some measurement services, support, and calibration of the system. So looking into the global network of API or the global presence, we have a full product as well as service capability worldwide. This said, we want to look today into the portable laser tracker technology, especially focus on applications in the aerospace. If you need more information about detailed specification, please feel free to reach out to me. Just give you a rough overview. We have 3 different types of laser tracker. In our portfolio, we have the Radian Core and Plus, which are battery-driven and fully integrated laser tracker based on the ADM technology. The Radian Plus, compared to the Core, can be equipped with additional accessories like the iScan or the vProbe. And the Radian Pro is the high-end, most trustable and accurate system, including a laser interferometer for full traceability. All this equipment can be, or for the Radian Plus and Pro, we can add tools like the vProbe for measurements of hidden points or deep holes or some smaller structures. We can utilize the iScan for scanning of surfaces, reverse engineering, and cut comparison. But this iScan also includes the probing functionality like we have for the vProbe. And in addition, especially for the machine tool or for robotic application, the active target or the smart track sensor can be added and support, especially if you have issues with line of sight. Today we focus on the tracker with the vProbe and the iScan. And as I'm used to be a more technician, I always want to see how it works and how we can do it. For sure, this is an online demonstration, so we prepared a short video to demonstrate how the process can look like. And we start with the vProbe, how we align against the CAD model, and we can see how it is done in Metrologic. So we're creating some reference points we want to use for the quick alignment against the CAD model. And for sure, I would ask Charlie or Clément to comment the Metrologic part.
Yes, I will speak. So as you see, the first step is to create an alignment between the CAD and the real part. And when it's done, you have to probe the same point on the real part. So as you see, we have a red circle and orange arrow. So you take the 6 points. We have a 3 point for the first direction, 2 points for the secondary direction, and the last point for the last translation. So when you are on the good position, the probe is green, as you see. So you take point number 3, number 4. Number 5, and the last. So when it's done, the probe is correctly oriented on the 3D view. And now you are able to define some features on the CAD. So now we have to define 6 circles. It could be plane, slot, sphere if you want. So you define the circle, and after you just have to probe the circle, and you have directly the result on the result table on the bottom of the screen. So circle number 2, and you can see the result on the bottom, on the side, on the right side. So circle number 5. And the last one. And now you can see stickers, so you can move the stickers as you want on the 3D view, and edit them. So if you want to show only the actual, only the nominal, it's possible. You have you can customize as you want the stickers. So now we will speak about the station orientation. It's the bundle, and the bundle is used for 2 cases. The first one is when you want to use different devices to control the same part. So, for example, one arm and one tracker, for example. And the second case is when you have to control the same part with the same device but on a different position. So now we have to take points on the real part with the 2 positions. So it's a powerful function. And to create bundle, you have to use specific point called orientation point. And when it's done, we have to take the point for the station number 2. So the station had moved on the real for the real part. You cannot see it on the video, but the station move. And when it's done, you use the function bundle to match the different point with the different station. You click on OK. You can see all the points from the station number 1 and the station number 2. And you will see the ghost of the 2 stations on the right and on the left. And now we'll speak about the live color mapping. So thanks to the API system combined to X4, we are able to scan the part and create a live color mapping to check directly the deviation of the part. So you have to save your alignment before, and the color mapping display a color graduation showing filters deviation. So don't forget to do this to have a good calibration and use the correct optical profile. If you have, I don't know, a shiny part, a white part, a black part, you have to adapt on the program the good optical profile to have a better result. And when it's done, you can scan all your parts, and as you see on the screen, you have the colorization of the part with the scale that you can adapt if you want. You can show only I don't know, the min and the max. You can adapt the min and the max. Play with the colorization if you want.
Maybe if I can just add at the end of these video demonstrations. From the hardware side, so with the first session or the first part was measured with the V probe. and then we relocate the tracker and use the backside of the part to scan. And with the flexibility of the eye scan, you can see also with orientation in different way, we can measure the edges, which are also hidden on the other side easily. So this was the short demonstration of the equipment, just showing a little bit the process from do the alignment, do some probing feature measurement using a probing system like the vProbe, and combine it as well with the scanning solutions of the eye scan, which can also be used by the probing functionality. So I hope this give you some ideas about how Metrolog and API can support your daily tasks. And we are more than open to listen to your questions. Please use the Q&A or the chat functionality here. And feel free to raise up your questions, or if you want to see a little bit more questions or information, sorry. It's always challenging to ask the first question, but don't be shy. If there is no question, it's always a good Does the laser tracker need a time to heat up before doing the job? This is a question for API, I assume. Yes and no. Depends on the technology. So we have the Radiant Core and the Radiant Plus, which is an ADM system. These systems are more or less instant on and can be can measure immediately after the start. If you're looking for the Radiant Pro, there's a laser tube built in, and the laser tube needs about, let's say, 15 minutes to really warm up and become stable. Environmental impacts, like if you put the tracker maybe in the back of your car, will change this situation, as you need to make sure that the thermal extension of the tripod and so on might be different. But from the technology side, the Core and the Plus do not have a heat time, and the Radiant Pro with laser tube needs some about 15 minutes. So we see here, do you have a service catalog for potential use case on assembly line? I think this is also related to API. For sure, we can give you some ideas about your application. I would suggest that we may get in contact afterwards with some more details to understand what is your assembly line and how we can support you. There's another question, is there different between the probing with the vProbe and the probing with the eye scan itself? In general, no. Actually, the technology which is built in for the vProbe and the eye scan is the same. So if you're using the probing functionality, you will more or less achieve the same results. That's always interesting questions, and for sure, and please, there's a question, what is the price range of a laser tracker? I don't want to mention pricing here in this particular meeting, but if you have a dedicated project and you need to understand what kind of pricing is considered, we can have an offline discussion. Please keep in mind, and if I look at Charles and Clement, laser tracker always includes software packages. So the full package depends on different variables. So if it is a 3D tracker only, and you may have just a low feature software, or you have the high-end software with all the features included, plus scanning, plus probing, and whatever, long range, then you have a completely different pricing.
Maybe I can add something about yes, it's included in the package, in the full package, because the package is done to the side of our partner as API. But just to give you the value of the side of the software is around 13K euro to get probing and scanning capability, just to be in mind when you will receive probably the offer of Jan for your case.
Okay, thanks. Thanks, Charlie. Okay, I think there's one question which is a little bit more related to Metrolog. What kind of alignment tools you have in Metrolog?
Clément or myself?
Yes, I can speak. Yes, we have a lot of alignments available. We have the quick fill, for example, for the Pine Cloud. So you have to click similar point on the cloud, the scan, and on the CAD to match and create an alignment. You can use, for example, the geometrical alignment to use datum, for example. You define on the CAD and you probe or you extract with the scan. So we have a lot of alignment available, yes.
Okay. Good. There's one more question, which is about the range of the laser tracker, not in regards of pricing. It was about the range of a tracker in distance. What is the distance for, or the maximum distance for our laser tracker? Depends also on the model, but we can, by default, for example, provide a 50-meter range, not diameter range, for our rating Core and Plus. And there is an option to increase up to 80 meter. And typically, a question, it's not written here yet, but the next question would be, can we use, how far we can use the accessories like the V-probe and the iScan? It can be used for the full range as well. So our technology or our sensoric is in the V-probe or iScan, and we do not have any maximum distance or minimum distance to use our accessories like the V-probe and the iScan. So that's maybe an advantage also to the competitive systems, that you achieve the full range up to 80 meter with a V-probe easily, and you can use, especially in the aerospace, use the system for large volume measurement, as Charlie also mentioned in the beginning. Okay, good. There's one question regarding GD&T. I think that's also more related to Metrolog. Are you able to create GD&T in your program?
Yeah.
Yeah.
So,
yes, you want to speak, Charlie? Okay.
yeah, maybe I can speak about that one. Yes, of course, in the Metrolog software, you are able to retrieve the GD&T from a PMI CAD. That's an help, I would say, because it's already done by the design guys, if it's well done as a semantic characteristic. But of course, if you don't have this good designer, I would say you are able to create your GD&T inside the working session of Metrologic, define it, and then as soon you evaluate the necessary feature, like flatness, you need a plane. When as soon as this plane has an actual value, the GD&T evaluation will be automatically associated to this plane. So for sure, you can do it from the application. And of course, you can teach that in your part program if it's necessary to replay this sequence for a new parts or for a couple of parts in your process. Did it answer to your question?
It was not my question. It was a question in the chat.
Okay.
But I have a basic rule in my conversations here. If nobody complains, everybody agrees. So it seems to be okay.
Okay, thank you.
Okay, good. Seems like we are coming pretty close to the end. No further questions, maybe just a few minutes or a few seconds if there is anything else. Otherwise, here. There's one more question. When we measure in a temperature changing atmosphere, can we compensate by hardware or software? I think at least from our side, let's start from the hardware side. Our laser tracker are equipped with a weather station to monitor the current environmental condition in real time. And depending on the changes, we always compensate the measuring values to fit the actual atmosphere requirements. Coming back to the software, I think that's something Metrologic can answer in a better way. We can talk about temperature compensation, maybe.
Clément or myself, let me know.
Yes, if you want. Yes, you can do it with the soft also. Yes.
So let me add a couple of items here. In fact, in the software, we are able to store all the raw data coming from the hardware. So we know exactly when the temperature will be changed, when we have to get a warning for the user to say, hey, take care, you have your environment, it's changing. Maybe you have to create a new set of environment, let's say a new station. And after that, during the bundling activity or during the computing, we are able to make temperature compensation according to the position, according to the point you are looking for, through the different scale data. And in order to get at the end a global working session with different variation of temperature according to the environment, for sure. So no worries about that. The large-scale metrology capabilities is well known by Metrologic since now, let's say more than 20 years, and through the different experience with huge parts or let's say shop floor not stabilized in terms of temperature on our customer plant, for sure.
Okay. I think long answer, but we can summarize it. Yes.
Yes.
Yes. Okay, good. If there's anything else, please feel free to reach out to us depending on your requirements. You can contact me directly. I can forward it to my colleagues or to my partners. If it is related to the software, feel free to reach out to Charlie or Clément. And if you don't know if the question is reflecting hard or software or the combination, feel free to reach out to anybody of us. We can make sure that we talk to each other and give you the answer you are looking for. You have the email address here, so feel free if there's another question or additional information required, just send us a note and we can follow up. This said, I would really thank Metrologic for this nice webinar, for the preparation, the support in the preparation, and also during the nice welcome for me during the video shooting. And I'm really looking forward to solve your individual's demands. And I would like to thank for your attention and for sure the French Metrologic team for the support and for the for the webinar today.
Thank you, Jan.
Thank you. Thank you.
Thanks too. In this case, I wish you all a nice afternoon and hopefully see you soon, talk to you. For me, the webinar is closed.